Hi and welcome to this lesson. We're moving on to electric fields today and we're looking at Coulombs law. So, Coulombs law. The equation for Coulombs law is F equals 1 on 4 pi epsilon naught times QQ over R squared, where F is the electrostatic force, Q and Q are the charges of the two objects, R is the distance between the objects, and epsilon naught is the permittivity of free space, which is 8.85 by 10 to the minus 12 farads per metre. And that's a measure of how easy it is for an electric field to travel through a medium. We consider air to be a vacuum, and if we're looking at spherical objects, we assume that we're looking at a point in their centre. Now, if we compare this equation with the equation for Newton's law of gravitation, we can see that on Newton's law of gravitation, F equals gmm over r squared. Now, that's actually really similar to this. G and 1 over 4 pi epsilon naught are both the constants of proportionality in these equations. Then, in both cases, the things are over r squared. And so the only difference is that for Coulomb's law, we're using charges instead of masses in Newton's law. So if we look at those in terms of our word definitions, the definition for Newton's law of gravitation was that the force between two masses is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. Now have a think, if we are just changing mass to charge, Coulomb's law then tells us that the force between two charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. So we are literally only changing the word masses for the word charges, and that changes the two definitions. If you've learnt one, you've learnt them both. Okay, have a go at some questions, see how you get on, let me know if you have any problems.